So 1V. Oh, this is what I hate to see. That was extremely dumb of me. I hit the chip with my hot air nozzle. This is already not working. I don't know what the fuck I'm doing here. Oh gosh, I think we're finally booting. Thank goodness. I cannot believe it. Hello, this is Aaron with iBoard Repair, and today I'll be recovering data from an iPhone 13 Pro by working on the motherboard and performing a full RAM swap. So this is the phone, and it just went flat dead on my customer with no warning. The screen just turned black, and I've already done a lot of work to this phone. I've already removed the motherboard, and aside from that, I've already done a full CPU swap. So I've moved over the important chips to this motherboard. So let me show you what I have so far. So this is the original motherboard. And as you can see, I've already removed the CPU, the NAND, and the EEPROM chip, and I've transferred them over to this board. But the very first sign that I was seeing on this motherboard was an abnormal amperage draw. So when I take my DC power supply probes and I touch them to the battery connector and prompt this phone to boot, it was doing, well, it's doing the exact same thing that it's doing now, even after the CPU swap. So that's one way to tell that your CPU swap is successful, is if you do a CPU swap and you see the exact same behavior as before, you know the physical aspect of the CPU swap went okay. So when I prompt this phone to boot by shorting the power button, we could take a look at my DC power supply. And this is exactly what it was doing when I first got it. So it will show the 0.12 or 0.13. It will jump up to that 0.3 and then it'll drop back down to 0. And then it's just going to current loop. So it's going to continue to do that same thing even though I'm not shorting the power button anymore. It will jump up, jump back down, and then restart. So that was the same behavior that I saw when I first got the device. And aside from that, there was no damage to this board. So there's damage now since I've already done a lot of work to this board and I've removed some chips and stuff like that. But when I first got it, there was no damage. The only thing I noticed at the very beginning was that I was getting an abnormal reading right here on one of my image lines. And I almost actually thought this was a no image device because of this. Because the customer did kind of make it seem like it was only just no image. And I think I was tricked by the DC power supply boot sequence at first. I think I let it go as soon as it jumped up to 0.3, so I just assumed it was booting and I didn't let it do that boot loop. So I thought this was booting at first and it just had no image, which is why I was measuring this connector. But this line right here, it was 0.31 when it's supposed to be something like 0.53. And I did actually notice that between the 13 Pro and 13 Pro Max, the readings are different on this line specifically, and only this line. So on the 13 Pro Max, the 0.3 is normal, but on the 13 Pro, the 0.5 is normal. And I even verified that with some donor boards. I can show you on ZXW. So this is the line that we're looking at, and we have a 13 Pro open, and I'm supposed to have this 0.5 reading on here. And it goes over to my display IC, and it goes over to those resistors, or to that resistor. And on the 13 Pro Max, we can see that same line, it's the 0.33 instead. So it's pretty strange. I'm not sure if this value should have been fluctuating. Maybe some gate opens and it shows a different reading sometimes. I know like some audio connectors do something strange like that sometimes. So maybe this reading can just be different sometimes. It's really confusing. It really shouldn't be any different than the 13 Pro Max, and 13 Pro shouldn't be any different. And again, that's the only line that's any different. But either way, this kind of got into my head, and I was trying to figure out why this line might be incorrect. So I had removed my display IC. And another thing I had noticed was this side was always giving me the correct reading of like 0.28, something like that. So I was always getting 0.28 on this side. But on this side, sometimes it would give me the 0.5 and sometimes it would give me the 0.3. It would just jump back and forth. And that really made no sense to me. But this side is my SD-RAM line, and that just really got in my head that this, or the SD-RAM 1V8 power rail. I could tell just from where it's at on the CPU here. So it really got in my head, you know, maybe something is wrong with RAM, maybe something CPU. I wasn't sure. At this point, I had done a lot of work to this phone, and I just decided I'm just going to CPU swap the device. Maybe I'm barking up the wrong tree here. Maybe this line should be fluctuating or something. I wasn't quite sure, so I just did a CPU swap. And one thing I should note is after the CPU swap, the reading on that line did go back to normal. So it is 0.5 now, 0.51. So again, I don't know why that was. Honestly, this doesn't really matter. It's just what I was kind of really concerned about before I did the CPU swap. That's why I'm talking about it so much. But in the grand scheme of things, it doesn't matter too much. That's now correct, and this phone is still doing, this board is still doing the same behavior that it did before the CPU swap, which is that amperage draw. Now, something to note about that amperage draw is that is what it will also look like if you have RAM completely off of the board. So if I were to take this RAM off, I should still see, I'm not exactly sure if it's exactly that amperage draw, but you do see a current looping amperage draw. And if I plug this phone into the computer, it will go to DFU mode, but only if I use the Force DFU pad here. If I don't use the Force DFU pad, it won't go to DFU mode, and it won't go to recovery mode no matter what you do. But that's the exact behavior that you'll see if RAM is off of the CPU, is a boot looping current that will go to DFU mode only if you force it with the Force DFU pad. So just because this line was so much on my mind and it was going to the 1v8 SDRAM, and now I've already basically eliminated every other variable possible, the SDRAM is really the only thing I've left. I've already, a CPU swap makes sure that everything else is fine. This board was booting before the CPU swap, so that assures me that all the chips are good, the PMIC is good, everything's good. The only things that are from the old device are the NAND, the EEPROM, and the CPU. Anyways, I've talked a lot, and I'm not sure if I made much sense or I gave enough of a justification. But either way, I have a gut feeling that my RAM has died. And normally, if RAM dies, you'll see like a short on the RAM lines, and we don't see a short on these lines. I believe this is my 1v1 line here, and it's giving me 0.06, which is normal. Here's my OV6 line, 1, 2, 3, 4, 5, and this should be 0.12, 0.15, that's normal. And then my 1V8 line is this capacitor here, and that's 0.28, and that's normal. That 1V8 line is also the one that goes into these resistors. So diode mode readings are good, the voltage on those lines is good, but that's not to say that the RAM itself might not be dead. So let's just get started with it. I'm going to remove RAM. Like I said, this has already been CPU swapped, so we can see the solder balls underneath the CPU. I'm going to test the current draw when RAM is off the board, and I want to see if it's exactly the same or if it's at least similar, which would be like a current looping amperage draw. And we'll go from there. So let's just start. It's not very common that I would just do a RAM swap off of a hunch, off of a hunch. But I just think it's going to be RAM this time. And I don't know if that 0.3 value on that connector had anything to do with what the problem is, or if it's normal for that line to sometimes jump back and forth between those two diode mode readings. I keep saying this, but you know, it just had me thinking about RAM so much because I was so locked in on that problem before I did the CPU swap. So in this video, I guess to sum up everything, I'm just going to be doing showing the full process of a RAM removal and replacement. I may have a donor or I may have to harvest one. I'm actually not too sure. But let's just go ahead and start. RAM is also the only possible problem left that would still be recoverable on this device. If it's a CPU problem, I can't do anything. NAND problem, can't do anything. EEPROM problem, can't do anything. So that is another bit of more motivation of why I would want to Well, I'd really hope it's RAM at least. And at this point, I don't use heat at all. I can just scrape away RAM with a razor blade. Done it a few times at this point. I do use a lot of razor blades. It cuts a lot better when it's very sharp. So hopefully I can get this removed without causing too much damage to the board. I can still go deeper than this. I haven't hit the spot I like to get to yet. I will probably release this video first, but I do have another RAM replacement video, and that one was a intense job. I think I have like 8 hours worth of footage, but I have all the footage of the initial diagnostic, the initial CPU swap. I did a CPU swap before a RAM swap, and then I had several problems getting the RAM to sit properly, and I had to do that like 3 different times. So I have a lot of footage. And it's just going to take me so long to get that edited, even in a very rough format. So this video will probably come out before that one. And that's how wasteful I am with these blades. Like you can see, I mean, this blade's not very chipped yet, but it's already not cutting nearly as well as those first incisions. So I'll be replacing it very soon. I'll go through like 20 or more, probably even more blades than that when I'm done removing this full thing. There's actually quite a lot of room for error in this as well. Even if I scratch pretty deep into this black substrate, the CPU is actually like way below this. And you leave this black substrate on there just as like a cushion. But it's kind of fine if it's cracked or damaged or anything like that. Another thing I'll be curious to know is whether or not the value of those resistors change once the RAM is off the board. It may, but it may not. One thing that's pretty hard to do is not damage all these components, and all these components are around the side. To be really aware of how big your razor is. And again, once I have this RAM off of the board, I should see a very similar, if not the same, current draw as I do right now. I do have two general shapes I like to use, and it's getting really tight in this area. I have this fatter iron, or fatter razor, and I have a skinnier one, and maybe I'll switch to that for this section. This one's a lot smaller. It dulls a little bit easier than the other one, but maybe the angle will be better to get this side. This one will actually snap every once in a while because I put kind of a lot of downwards pressure on it as well. I don't know about this shape. And these are the Swan Morton blades. And anywhere in America, they're very expensive now. Like obscenely expensive for a box of 100. I can't remember. It was like $80 or $60, something. I think it was like $80. That's just too much. So I can find them on AliExpress for something like $20, which is still kind of a lot, but it's not nearly as bad. There we go. Okay, connecting the two sides is usually the hardest part. There's still a lot to go, and it will still take quite a while, but it's always a struggle is getting the two sides connected like that. Now I can use the flatter edge of this fat blade again, which is the easiest way to get this up. As you can see, it just chips into my blade very, very quickly. So I'm quite liberal with my use of blades and somewhat pretty wasteful, but it's worth it for a clean removal. Some people use, I mean, I don't know if anybody uses Dremel. There's very few people that do ram work at all, but I know like I've seen posts of Rico Curva, however you say his name. He uses a CNC drill to remove RAM, and you know, I actually was gifted a CNC, but I never got around to setting it up or using it. And at this point, I'm fairly comfortable. It might take a little bit of time, but I'm fairly comfortable removing with a razor blade. RAM work is not super common anyway. It's very scarcely needed. And this is basically the only time I've ever done it on just more of a hunch than like concrete evidence. So it's not something I do often. And most of the time, I'll find my RAM line short if I'm going to remove RAM. So my 1V06, my 1V8, and my OV6 line. When those are short, it can often be the fault of the RAM chip itself. Not always the case, but it can be. It's a bit of a slip. Luckily, I don't think I damaged the capacitors. Almost there. Okay, so I'll just do another rough pass over to get most of this copper off the top. There are a couple spots I went deeper than I would have liked, maybe, like right here. But again, it's not really going to matter. I have a lot of room for error on the top of this. I will have to get the top very flat, so when I put the ram down, it sits flat. And yeah, that can be a little bit tough. This board holder is kind of annoying because it comes loose a lot, but there's a lot of reasons I like it for this job. For one, it's flat and supports it completely around the outside, so if I push down, there's always going to be some good support. And then on top of that, it's very flat on top, so I don't like hit anything when I'm coming with the razor. In the past, I've tried to use low melt solder when reballing the RAM, but I've learned that leaded solder gives me a lot more like stability in my solder balls, and it really helps with RAM. So I use 183 instead of the 148 that I may have used in the past. Eventually all of the green will be removed and I'll be left with just black. But right now, I just want to get to testing the current draw and making sure it's still being recognized by the PC NDFU mode. So I just want to get the copper off. Well, that's interesting. I don't think I snagged this or pushed this down so hard that this would have came loose, but I do appear to have like a crack here. Maybe my CPU was cracked the entire time. Because I did not notice that before. I don't think it would be possible that I would have chipped this in any way other than... I feel like that had to have already been like that. It's very interesting. That had to have been what the problem was this whole time. Hopefully that only affected RAM and that's not affecting my CPU. I really don't understand. When I was reballing the CPU initially, I didn't see any problems there, so I'm really hoping the CPU is okay. It's really close to the outside. Alright, RAM is off enough that I can test to see if it's still giving me that same amperage draw, and test to see if it's connecting to the PC in DFU mode. It should be still giving me some sort of boot looping current draw similar to what we already saw, and it should still also connect to PC in DFU mode. However, I have a crack in my CPU here. And again, this black substrate isn't actually the CPU. The CPU is super thin. It's at the very, very bottom. But this looks like it's going pretty far down. Basically all the way. But when I was reballing the CPU, I didn't notice any cracks, but I wasn't really looking for them. And if it's so small, I may just not have noticed. Okay, well, it's weird that the CPU would have been cracked, because like I said, the phone was largely undamaged, but that's not to say that, I mean, I have two of them. What the heck? How did that happen? I mean, I don't think it's possible that I could have caused that. Unless it was already very compromised. But I've removed RAM, I don't know, half a dozen times before, and nothing like that has ever happened before. So maybe these were original problems on this board. I'm really not too sure. It's very strange. I've never seen this. I'm lucky it's very close to the edge, so maybe even if the CPU is damaged, it's just like ground or something. But I definitely am curious to see if my amperage draw is or just what it looks like. Okay. Let's see what we got going on. So DC power supply probes. Touch them to the battery connector. Normal so far. Short the power button. Okay, that's normal. The spike up to the 0.3 isn't what it would normally do. Now that I'm seeing this, this looks like what I would normally see with RAM off the board. So the amp draw before I removed the RAM was still a current looping amp draw. It just didn't shoot up to that 0.3. And that 0.3 may have just been the RAM trying to turn on, and maybe it was damaged because of these points or something like that, and it couldn't after it tried to, so maybe we're still okay. Let's just double check to make sure this still connects to the PC. I can do that by plugging in just a charge port and a battery, and then I can use the Force DFU pads to inject 1.8 volts into there, and it will go to DFU mode. So I'll set my DC power supply to 1.8. I've already plugged in my charge port to I plugged in the board to the PC. As you can see, well, not really, but it's not connected to the PC. And once I inject, it will connect, or it should connect. And there we go. We have an iPhone 13 Pro in DFU mode. So that's all normal behavior with RAM off the board. But I am quite concerned with these chips I have in my CPU. I really wish I would have taken video of the CPU swap just so I could have checked the footage and seen if I saw any type of damage around this outside here. So I still have quite a lot of work to do. I need to flatten these pads all of the way. I need to make sure I'm very flat. It's not too bad, but I want to get rid of all the green here. I don't like the middle to be higher than the outside. And I just need to make sure this is all the way flat. And then I do believe I have a donor RAM that I got from AliExpress. And I have one here. And I'll have to reball it, but that's fine. So only two things should happen. I should either have the exact same current draw I had before I removed the RAM. So you know that up to 13, then up to 31, and then back down and looping again. Or I should have a booting phone. Anything else means the physical process went wrong. I should have either the same behavior or a working device. If I have the same behavior, I can probably assume that CPU is damaged, and that's why it's not booting. I shouldn't have any type of different behavior. I shouldn't have the behavior that we're seeing now, which is only 0.12 and then looping. It should do the 0.12 and 0.31. Otherwise, that would mean that my RAM's not fully connected. So either old behavior or a working phone should really be all I expect here, unless I did something else wrong as well. Sorry about that, didn't realize I was still on that large screen. As you can see, this part goes fairly quickly. Okay, looking good enough to me. I'll go ahead and reflow these pads now, and some of them may get messed up in this process and I may have to like put solder paste down, but it's necessary. When you apply heat to these pads, sometimes the solder will like suck downwards because there's like a tube almost here, like a hollow spot below here. Not really hollow, but like there's space under there. And when you apply heat to it, sometimes these pads suck down, and when that's the case, it may mess up the RAM if I don't reball it first, or like reflow it first at least. So I'll just use my normal solder for this. Like I said, in the past I've tried to use lower melt solder, but I find it to be like too brittle and not like structurally sound enough to support the RAM. I probably should have used more flux or something. I'm not super excited with how those pads reflowed. I'll definitely have to go over this with some solder paste to make sure that I have good balls in each one of these holes. So like I said, I'll just use normal 183 solder paste. Especially because the CPU's already been reballed, I don't have any like protective underfill along the sides of the CPU. So I have to be very careful that these solder balls don't spill over the side of the CPU. Otherwise it's gonna flow underneath the CPU and I'm gonna get bridges on my pads and my lines under there. Alright, this looks good enough to me. So let's reflow all these holes with more solder. And then after that, we will reball the RAM. And then after that, we'll place it, and hopefully everything went okay. And really, hopefully this phone will just work. At the very least, I would like to see the same behavior to know that I didn't mess up any process, but you know, that's not going to do me any good if I can't get the data, so hopefully the phone will just work. I'm lucky I've already used this same solder underneath the CPU, this 183. If I use low melt under there, it might kind of worry me a bit more, but it's the same solder I'm using on the top. In a lot of old or past CPU swap videos, you will have seen me use 148 solder paste on the CPU, but I've recently switched to just using 183. I just find it to be more stable. Okay, I think that looks much better. Much more likely that the RAM will take hold. So let's just re-roll RAM now. I'll wait for this to cool, clean that off one more time. In the meantime, I will re-roll the RAM. So this is freshly CNC'd, as you can tell, or as I can tell. And it will have the same issue where if I run an iron over it, it will like sink down some of them. But in this case, I think I'll just go ahead and try to re-roll it as it is. This is actually the wrong RAM chip. This is a 16, which is iPhone 14 Pro. My A15, I've actually done one RAM swap before, as you can tell. I have a couple different RAM chips here. So this is the one I got from AliExpress, but I ended up liking the one I harvested better, which is on this CPU, which this was a successful data recovery on this RAM swap on this CPU. So I think I'll just go ahead and probably pull this RAM off of the CPU and reuse this one. This one was actually harvested from a fresh CPU myself with a razor blade rather than bought from AliExpress. Might be kind of hard to get in here. I guess we'll see. So you can see the RAM looks quite different when it's been harvested. But I think this one will probably work better. This RAM was almost undamaged. Should have, I mean the balls are almost undamaged. There's that CPU that it was attached to. And it just makes a lot more sense for me to use the RAM that I already know has worked one time. I know that the RAM's good. I know that it gave me data before. Might as well use it again. And it would have been nice to show you the process of harvesting a RAM like this. Like I said, I have another video of I already have footage of another video of another procedure where I did a RAM swap, and that was actually included. This harvest was included in that video. It's just that I have so much footage on that one, it's going to take me a long time to edit. But I will probably get around to releasing that, just because I found that YouTube tends to very much like my very long videos. So that's an 8-hour video, and I'm probably just going to release it largely unedited, just as it is, so you can see me struggle and just suffer. YouTube will like that. But I'm fairly positive I'll release this video first, just because it won't be so hard to edit. I actually have a backlog of footage right now. I have like 5 videos filmed, and I've been extremely busy, so I haven't been able to edit those videos and release them. But I want to, and I will eventually. The summer months tend to be my busiest months because a lot of people will find me for water damage. I have a lot of good SEO for water damage data recovery, and in the summer is when people will be water damaging their phone the most. So I'll try to reball. I do like to hold the stencil down kind of hard because I would like not too much space between the stencil and the chip. On smaller chips it doesn't matter too much. On the CPU I have a better jig that just kind of does that with a really strong magnet. But especially with RAM, I've had trouble seating RAM in the past. I've had trouble with line shorting. I've had trouble with the RAM not like seating or attaching well enough. So I try to get as perfect a reball as possible on it when I can. So let's see if I can reball this. This stencil is a little bit harder to reball with than like a magnetic stencil. It's not even a 3D stencil. I actually wish these tweezers were on the outside now. I don't know why I put them on the inside. Not perfect, but I think we're going to be good enough to work with. I have a few balls that haven't attached, I can see. I don't really like putting flux onto my stencil because it's a bit hard to clean, but in this case it's going to be necessary. It doesn't look too bad. I think we're probably okay. Looks pretty good. I'll just give it one more reflow with some flux. And once I clean this, I think we should be good to put this on the board and we can see if everything's working. Alright, I think it's time to place the RAM and let's see what we get. Probably good enough. I do tend to stress over my alignment, but it's probably fine. Looks like a good temperature, 289, 17 air. I'm very random with my temperatures. That's all that means. I want low air and pretty low heat to start off. bump up the heat a little bit. I'll up the heat a bit more. 350's as hot as I'll go. So this is my final temperature, but I will bump up the air probably one more time, or one time at least. I just want this to somewhat settle first. I would also like to see some flux coming out of the side, though I didn't use too much. Probably won't see the flux. I might. So this will be my final temperature and air. This should settle the CPU and RAM just fine. Okay, and that should be plenty enough heat for that to have attached by now. So wait for it to cool, we can take a look at it, and then we'll test the boot sequence, and then we'll plug it in. Alright, let's see how it looks. I don't see any obvious bridges, so I think we're going to be okay. But I do always like to check the RAM lines first, make sure they're not short. Because in the past I have had shorted RAM lines just by placing the CPU. Not from a bad RAM, but from bad placement. So 1V. Oh, this is what I hate to see. So my 1V06 is short. 1, 2, 3, 4. OV6 is not short. And let's see if 1V8 is short. 1V8 is not short. So only Only 1v06 is short. Oh, that's very annoying. Very, 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 very annoying. So I'll have to lift it back up and replace it. And I can normally see, once I pull this off, the solder spot that got short. I see that chip did fully come off, which is a chip in the CPU, which is a little concerning. So hopefully the short is actually at the RAM chip and not underneath the CPU somehow now. And this is why you never want to work on RAM, because this is just so common. Jesus. It's already getting late at this point, and I don't have much more time to work on this. So how was I able to get RAM off before? So if I'm lucky, I can just kind of flick RAM off and nothing will be too disturbed. And hopefully I can see whatever bridge happened. I'll just try to clear that bridge and then place it right back down if I have no disturbance in my solder balls. But that is easier said than done, because it's hard to pull RAM up once it's already down. Is this how I did it before? I don't even remember. I've done this before, it's just, it's hard. And I had quite a lot of bridges. So all the solder is still on CPU here. This is part of the reason why the other video I have with my RAM replacement that I was talking about, that I just have the footage of and haven't released yet. I had shorts multiple times after replacing the RAM. And I don't know how to avoid this. It's very common when working on these newer models for me to get these shorts. But if I just clear the shorts without disturbing anything else, I'll try to just put the RAM back on, and maybe the right amount of solder will be on it the second time. I'm completely missing this ball. So it may have been sucked into the one next to it. That's possibly from bad placement. So I'll just try to stick this into here. Over here I have quite a lot of bridges. I think it will work if I just clear these bridges and then put the RAM right back down. And then there will be less solder in these spots that had bridges. It's like the solder is not structurally sound. I already said that, structurally sound enough. Like if the weight of the CPU is too heavy, it pushes it down too far and causes these to bridge or something. I don't know why the balls can't just support the weight of the RAM itself. Huh? Yeah, I'm probably down about 15 minutes. Not yet. I need to keep working. I'm almost done. I'm almost done, babe. Alright, I'm just going to place this back down. And let's see if it will grab hold better. And if we have no shorts afterwards. I think I cleared enough solder that it will be okay. I think the low amount of heat that I use plays a role in this, like, grabbing the bowl next to it type deal. And maybe if I'm using higher heat and everything liquefies closer to at the same time, then it will sit more evenly. So let's give this another shot and see if it will sit better this time. So we'll take a look at that, see if it looks any better, measure our lines again, see if we have any shorts. I may need a bit more flux, so I may have to reflow that one more time. I can see bridges again, unfortunately. So I'll have to do that process again. I suppose every time I clear out a little bit of solder paste, it's less likely to bridge, but I definitely see bridges again. I see two of them. See one right there, and another right there. Let's see if those are the only two, or if there's more. Unfortunately, I have no more time for tonight. It's already late, so I'll have to finish this up tomorrow. But let's just pull it off one more time so we can see. It pulled off fine last time, so I'm sure it will do that again. I don't think this solder ball probably didn't attach to these spots in here. So I may actually need to put a little bit more solder paste into these two holes at the very least. Very most, whatever. But it does appear only this section had a few bridges. So one more try and I think I should be good after I clear this solder out again. My pads are getting somewhat gray though, unfortunately. And the grayer it gets, the less likely it's going to attach to the ram. So I don't feel like my reball was uneven. So if you can think of a reason why these pads bridge, let me know in the comments. It'd be helpful if I knew what these balls were. That way I could tell if I, can just leave them not connected or not. But for all I know, these are very important. I need quite a lot of solder paste in these two holes. I don't know why, of all the holes here, only these two are pretty disconnected. Those still aren't as big as the other ones, but hopefully that's fine. Alright, let's just see if I can do it one more time. It's already late and it's supposed to be done, but let's give it one more go. These pads are somewhat gray, but they're not too gray. I think they'll work. As they say, third time's a charm. Let's get this done. Really just don't want to see bridges right here where they keep happening. Every time I remove a little bit of solder, there's going to be less likelihood of it happening again. So even if it happens one more time, that's fine. I'll just keep doing this. But this is my last try for tonight. Okay, last try for the night. We'll see how that looks in just a second. Okay, I don't see bridges this time, so I think maybe we're okay finally. Okay, I don't see bridges. Hopefully we're okay this time. Let's just measure the lines for shorts again. Check 1v8 first. Good. Check out OV6. 1, 2, 3, 4, 5. 1, 2, 3. Good. And 1v1. Come on, 1v1. .06 is normal. What are we getting? It's a little warm, so .04 should be fine. I mean, .04 is a bit lower than what I'd like to see, but I'd rather see .06. Let's see. Okay, now it's cold and it's higher. It's fine. Okay, so I'm pretty satisfied that there's no shorts on the ram lines. Let's do a, it's prompted to boot. Check the current. So that looks more like the RAM is not connected to me now. Because we're not seeing what we saw when the RAM was connected, we're seeing what we saw when there was no RAM on the board at all. So tomorrow I'm just going to apply flux around the outside and tap the RAM a few times and see if it will get connected. I've had that work in the past. But tonight I need to go spend some time with my daughter and eat my dinner. And this is a shame. This is why RAM works really, really hard on these newer models. Okay, I'm coming, babe. Okay, I'm back today. I do think I was getting way too impatient yesterday. And I even realized I was pulling the RAM off differently than how I normally would. I'll normally just pull it like this and lift it. This time I was flipping it, and that was leaving all the solder on the top of the CPU rather than on the RAM. But when I lift it like this, it kind of is more even. Maybe I should have done that. I know that the pads are probably just too gray to actually connect to the solder right now. But either way, I'm going to give it more heat than normal. and I'll tap it, and maybe it will connect and we'll get lucky. I'm fairly certain right now it's not connected, and that's why the amperage draw is the same as it was with RAM off of the board. So I don't really have to worry about overheating the CPU. It's already reflowed with better solder. There's no underfill. So I'll give it a good blast of heat. I'll give it a good twitch, and maybe we'll get lucky and it will just connect. If not, I'll have to pull it up again, and I'll try to maybe scratch the pads on the RAM if they're still super gray. Either way, I have to do something to get this working. So we'll let that cool, give it another shot. If it doesn't work, I'll just have to pull it up one more time and try one more time. And hopefully that will be my last attempt. That's really all the time I can spend on this device. I have a lot of other work to do. I'm actually swamped. So it's not great for me to spend too much time on devices that aren't even for sure fixable. It even kind of looks like some of those balls are not connected. So that's possible. See if I have any shorts on this side again. I don't think so. So I'll just test the RAM power rails again, make sure they're not measuring short. And this video probably has become quite redundant at this point, so I apologize, but I do like to just show my full real processes here. One V06 is good. One V8 is good. 1V1's a little bit low, but it's not short, and this is already supposed to be a little bit low. It's probably just because my board's still pretty warm. Okay, so let's see if we have anything different now with our DC power supply. I honestly hope it's different. Even if it's back to the original problem, I know I can stop working on this one. I just don't want to see that jump to 0.12 and then a loop again, because that's what I see without RAM. And I could be incorrect, but to me that indicates that RAM's just not connected if I see that. Yeah, so it's still showing me that sign that kind of shows like RAM is not connected. So I'll lift it up one more time. I'll see what I can do, and hopefully This will be it. That was a terrible lift. I both dropped it and pushed down on the CPU a tad bit, so I may have shorted the pads underneath the CPU. So no good. Maybe that's not how I did it, I don't know. I can see a ton of pads over here, probably never connected. Some of them did, but you know, without those connected, it probably just wasn't working. Now I have to see if my CPU is short. I hope it's not. It should still be doing the same amperage draw as we saw before. If we see like a quicker spike or a shoot up, then I shorted CPU. Okay, that looks fine still. It's a little higher than normal, but that's just because it's hot. So I think I'm just going to do the full reball one more time over and hope that it just will work. God damn it. That was extremely dumb of me. I hit the chip with my hot air nozzle. I'm getting tilted here. I might as well just reball it again in this case. God dang it. This is already not working. I don't know what the fuck I'm doing here. I can't even re-roll no more. So this time I'll grind down some of these solder balls to make them a little bit smaller. Especially on this spot right here. That's where the bridges were mainly happening last time. And I'll melt it into balls one more time and then grind it down one more time. And I think it should be good. And those balls did seem pretty big, so I guess this is a good thing I'm doing this. Alright, fingers crossed that that was the one. Check my lines again. Alright, let's check the boot sequence. Hope we're good to go this time. Actually got quite a lot of movement out of that. So moving it down, it like kind of stayed a little bit lower. So maybe it was out of place. But if not, honestly, I think I need to move on after this. Hopefully I'm not short now, which is absolutely possible. Okay, that's different. Oh gosh, I think we're finally booting. Thank goodness. I cannot believe it. Let me clean up this board and grab some parts and we can do some more testing. So, are we finally good? If we are, I'm going to be very happy. That boot sequence looked better finally. Um, it looked more like the first one where it went up. It went from 0.13 to 0.3, and this time it did not reboot. It went back down, but then it held steady. So I think it may be booting. And if this works, I'll be very happy because, like I said, this was more of a hunch rather than actual concrete proof that RAM was bad. And I honestly didn't really know if it would work. So, yeah, I was also very surprised to see there was like some small CPU damage, it seemed like, and I don't know. We have an Apple logo. I don't know when that occurred, but it had to have been part of the original damage. It was just strange because there's no physical damage to this phone, but even if the phone doesn't have physical damage, if it's dropped, it can absolutely still develop CPU problems. So that must have been what the original problem was. But I can't believe I'm seeing an Apple logo right now. This is absolutely great. And we are booting. There's not even a password on this device. Great, I'll unplug this for now. And yeah, like I was saying, this one was a lot of work. I did a lot of diagnostic work before I ever did the CPU swap. I worked on trying to figure out why that diode motor reading on the image connector was incorrect for a couple hours probably. And then after that, after I couldn't figure out what was going on, I decided to do a full CPU swap and just hope that maybe that would solve the issue. Even after the full CPU swap, this board was giving me the exact same amperage draw on my DC power supply, the same before and the same after. So when you see that, that indicates that your CPU swap went perfectly fine, but the problem was still present. So that really only left the possibility of RAM being the problem if data recovery was still going to be successful. And because the diode mode reading was incorrect on a line that connected to the SDRAM, it was really in my head that maybe that was the problem. As you can see, I struggled greatly with the RAM placement. That's happened a few times. Like I mentioned in this video at some point, I have a whole nother filmed footage of another recovery where I had similar problems where I just could not get the RAM sitting after multiple attempts, and eventually I did, but I have about 8 hours worth of footage on that video, and eventually I will release it, but this one will definitely be released first because it's a lot less length. What else? There was a... So basically what I was seeing was a phone that was giving me a DC power supply amperage loop, amperage boot loop, not an Apple logo boot loop, just an amperage boot loop, and it was going from 13 to 30, 0.13 to 0.30, and then back down to 0. And that's very similar to what you'll see with the RAM completely off the board. We saw in this video that when I took the RAM off the board, it would just go from 0.12 and back to 0. And when it's in that state, you can force it into DFU mode using the Force DFU pad on the board, and it will connect to the computer in DFU mode. And even when it was going from that 0.13 to 0.30, it was going to DFU mode, but it wouldn't go any further. With the RAM off, it did that same thing. It would go to DFU mode, wouldn't go any further, wouldn't go to recovery mode. And that's a strong signal that possibly RAM can be bad if you suspect it is a boot looping amperage draw that will go to DFU mode if you force it to and won't go to recovery mode. Anyway, this was a very long video, so I applaud you if you stuck around. Thanks for watching this one. Hope you have a good one. Hope you stop by again. Bye-bye.